Hello everyone and welcome to part 11 of my series about vSphere with Tanzu on NSX-T. Today we are going to conclude the series about vSphere pods and all related networking services in NSX-T, where we are going to deploy a demo application and see all the networking components which are configured as well. Additionally, we are going to look at traceflow in NSX-T to troubleshoot, for example, pod-to-pod connectivity. So let's get started. In front of us we have the YAML file. So on the right I have a front-end deployment, which is based on the Kubernetes examples for the guestbook application to demo that. I've downloaded the image already, and as you can see I've changed the image value to point to my Harbor embedded image registry for the alpha namespace. So it's dedicated project for alpha namespace. Besides that, we are going to deploy 3 replicas, and everything else I kept the same and per default. So let's deploy the front-end deployment. So the front-end pods in the deployment. kubectl apply, and then front-end deployment.yaml. So this will create the pods related to the front end of the application. Let's have a quick look at the Mongo deployment. It's the back end, so a Mongo pod for the database content. Simple deployment, just 1 replica. Again, image already downloaded and uploaded in the Harbor image registry, of which I changed the value, the image value. And this pod is going to listen at 27017. So that's important to remember, as where the front-end pods obviously listen on port 80. So let's deploy this deployment. Go deployment. So now we've got a back-end pod running as well, a Mongo pod. So if you do kubectl get pods, we can see 4 pods running, 3 front-end pods, 1 Mongo pod. The Mongo one is pending at the moment, and we can see the IPs allocated to the front-end pods. So we also make sure that we have a service running. So I already deployed a service to save some time for this video, and we're listening on a service type load balancer on 192.168.1.2 on port 80. And this service is obviously looking for pods with a certain label, similar to the previous examples. So let's see how that looks like. So this is just a very simple front-end service specification. Kind service, type load balancer, listening on port 80, and we're looking for pods with the name guestbook and the component front end. So as we can see, if we do a describe, service front end, we can see all the configuration, the configuration of the front-end service, and we can see it has discovered the endpoints being the front-end pods, target port 80, and the ingress IP being 192.168.1.2. Okay, so we are also going to need a service for the Mongo DB pod. So looking at the Mongo service, this is again a very simple service, and this is just exposing port 27017 and forward it to the Mongo pod on the same port as well. Then we select all the pods related with the name Mongo and the component backend. So if you now do get all, let's see what we have right now. So now we can see the Mongo pod is running as well, so that's done. We have 2 services and 2 deployments. And for the fun of this demo, I also created 2 network policies. So first of all, I've created a network policy for the front end. And this is going to be translated to a distributed firewall rules and being enforced at the vSphere pods at the virtual interface. So this is an ingress policy, and I'm only allowing ingress port 80 and obviously protocol TCP. So very simple example, matching the labels name component to allow port 80 inbound for the front end services, front end pods. So let's deploy this. So let's have a quick look in NSX-T right now, how that looks like. So let's start at home. And obviously we already have a namespace. So each namespace gets a dedicated tier 1 and a dedicated segment to start with. So let's check it out, alpha namespace. So here we can see the tier 1 gateway with at the moment just 1 linked segment. Because we just need 1 at the moment, and we can find the allocated address. So this is my gateway address, and on load balancing we can obviously see the server pool for the alpha namespace for the application we just deployed. So let me see Bravo alpha. So here we can see the virtual server listening on port 80, listening on the .2 address layer 4, and the server pool is consisting of the 3 front-end pods being discovered based on their labels. So that's that part. If we look at security, we can now see with the first network policy we created that we now have 2 rules being added actually. So first of all is the allow rule, which allows TCP port 80 ingress to a new security group being created automatically, which consists of the 3 IP addresses of those pods, the front-end pods. So this is automatically being discovered by the NSX container plugin, reading the Kubernetes API and creating related required objects in NSX-T. So the service would be TCP port 80 destination, and we only apply this policy to the virtual interfaces of the pods in NSX-T, so nowhere else. You may see in progress because this policy is being pushed to all related transport nodes, and sometimes this can show in progress for a few minutes. As you can see, once I refresh it successfully. So additionally, we also have a isolation rule or drop rule. So here you would see that obviously you only allow ingress. This requires us also to create an ingress isolation rule to make sure that if there's traffic not being matched by this rule, we can drop it. And this is that rule for that purpose, and only being applied to obviously the pods being a member of the security group, which is again based on their labels and being discovered automatically. So let's create another network policy. And I've prepared a Mongo network policy, and this is just simply exposing the Mongo port as ingress, port 27017 TCP inbound for the pods matching the labels Mongo component backend. Obviously we have 1 pod with those labels, so based on those labels this port should be exposed through the distributed firewall. So before we do this, quickly wanted to show that we have obviously also the application being accessible. Yep, seems to work, and we should also be able to have a message being stored in the guestbook. Cool. So let's deploy this network policy. So now the Mongo network policy is being created. And if we look at NSX-T, refresh this page, we should see two new roles being configured. So first of all, the Alpha Mongo network policy, which allows TCP 27017 ingress allow as the name. So the destination is a new security group consisting of the only IP, since we have only just one pod running Mongo in this deployment. And the service is TCP 27017 and only being applied to the Mongo pod. And again, we have an additional isolation rule to make sure that everything not being matched through this rule will be dropped and being applied only on the Mongo pod virtual interface. Cool. So let's show how you can use traceflow, for example, to troubleshoot this kind of firewall connectivity. So if you do a traceflow, you select a source virtual machine and a destination virtual machine. Since vSphere pods appear as virtual machines in vSphere, you can select the type virtual machine. So that's very cool. So we're going to test TCP, and the destination port is 27017. And we just select one of the front-end pods. It automatically discovers the network adapter. And the destination would be the MongoDB pod. This is it. So let's do a trace. So it will give me a message about possibly seeing duplicates because I'm in nested lab. That's all fine. As shown here. So here you can see that my front-end pod through the segment is reaching the Mongo pod, and if we look at the observation types in the hops, we can see it's being injected, received through spoof guard, forwarded to the distributed firewall, outbound, being forwarded again, forwarded through the physical fabric. It seems that the pod is running on a different host, so we have to jump from one vSphere host to another, and then being received by vSphere host 4, distributed firewall. It's being allowed, so the rule ID is also identified 1206, and we forward it, and it's being delivered finally to the interface where the Mongo pod is being connected to. So this is an example of a successful trace, but we can also do see what happens if it's on the wrong port or the trace is unsuccessful. So let's change the destination port. So it's the same path, the same topology, but here you will see, because the destination port is not being allowed by any firewall rule, it's being dropped by firewall rule ID 1205. So if we go back to security, to the distributed firewall, we can, it's most likely the Mongo isolation rule 1205, that's the rule ID which is dropping the traffic because it's not being matched by the previous rule we configured as a network policy, which only allows 27017 inbound. So this shows if you have some issues connecting to your pods, you can troubleshoot it using traceflow, and it will inform you which rules are in the path or are preventing you from being able to connect to those pods. So very, very powerful tool to use. So as a final proof, let's again do a test. And as you can see, it's successful. So this concludes the demo of a guestbook application run as vSphere pods on vSphere with Tanzu on NSX-T. And I hope you like this example. I will share the YAML files on my blog page on cloudextreme.info, so you can use them for your own tests as well. And hope you liked it, and see you next time. Bye bye.